computer. Awesome. All right, so I know you guys are here, so can anyone give me a little bit about IP? Nothing? Dead silence? What do we know when it comes to the difference between layer 2 and layer 3 addressing and forwarding? What do we do with layer 2?
Yes, I got it. Oh, sorry.
All right, so when we deal with layer 2, we're talking about MAC addresses, right? When we deal with layer 3, we're talking about IP addresses, which is why they call this logical addressing, right? The internet protocol is its main, I'm sorry, I'm gonna mute some of you guys because I can hear everything. Hold on one second. If you could mute yourself if you're not talking to me directly, that'd be great, so there's nothing in the background, okay? Okay, so internet protocol is responsible for moving packets across the internet, and it's also there for the logical addressing. Think of the internet protocol as the post office, right? So its job is for you to know the address as well as to send mail over the world, correct? However, if I'm, let's say, sending a postcard to Josiah or May, I don't have to tell them, hey, May, I'm sending you a postcard. There's no need for me to establish a connection, right? It is also unreliable. If you think about it, if I send 5 postcards, maybe one will get lost in the mail unless I go there and ask for that certified letter, right? So there are 2 versions, IPv4 and IPv6. Has anyone seen an IPv6 address? Nothing, guys. Wow, you guys are quiet this morning. Okay, so right now we're dealing with IPv4, and you guys should already know what it looks like, but we're gonna go over it in a second. So if you guys remember the encapsulation that goes through whenever we talk about the OSI model, so the first 3, you get a PDU, which is just the data. Then what happens to the PDU, a layer 4 header gets attached to it, and that now is called a segment. Then it goes down 1 level, and this is the level we're on right now, and it adds a layer 3 header, which is the IP, which is what you're looking at right now. It adds it to it, and now it's called a packet, right? So we were at data, segment, packet. So this is what gets attached to it. So you have your data options, not really used, but this is what that extra header looks like at this level. So the version is going to tell you what IP where we have, what version we have. It's either 4 or it's a 6. You guys see my, okay. Then we have the header length. So how big is this header without the data? DivServ talks about quality of service. So which packets are more important. So if you think about it, like a large file is going to get broken down into pieces, right? It's not going to go all the way. But what's going to happen is some are more important than others. For example, if your internet is slow, you have a hard time loading your page, that's one thing. But if you're talking like on Zoom, for example, and it's spotty, well, that's a problem, right? So pretty much this part deals with which of the packets should have right of way and which one are more important. Total length is the total length of the packet plus the segment, so layer 3 and the data. Identification, flags, and fragment offset have to do with if the packet gets broken down into, it gets fragmented, sorry. So if they do get fragmented, all of them will have the same identification, so we know where they're coming from. The flags, these should be 3 bits. The first bit is 0, the second bit determines whether or not it is okay to fragment the packet. And the last one tells, so you'll see in Wireshark, the very last bit will say, hey, yes, there is something else coming after me. And the fragment offset helps the receiver repiece the fragments back together. Time to live should be in second, but it's also used for the hop count. So we talked about layer 2, how we could have our network bogged down because there's no way for it to stop. However, at this level, there is a counter, we're going to call it, right? And as it goes through each router, the counter goes down by 1. And when it hits 0, what happens is the router will drop the packet. And that prevents this packet from going and bogging up the network somewhere. The next thing we have is the protocol. So is it TCP, UDP? Here will be number. I forgot the numbers. They're determined by IANA. So you'll have to look. I think UDP is like 6, but this right here will tell you what kind of protocol is in this the header. Checksum has to do with if there's any error within this this header right here. IP does calculate a checksum, and whenever it goes to a router, the router does another calculation. If the checksum do not match, the packet gets dropped because maybe the packet was malformed or something. And then we have the source address and the destination address, and these are going to be IP. So before that, the layer above it, so that was the transport layer, had the port, the source port and the destination port. This one's going to have the IP source address and the IP destination address. And the one right below it will have the MAC source and the MAC destination address. Okay? Option, rarely used. You don't need to worry about this. And the data, well, that's everything else in the data. I would like to also iterate the checksum, nothing to do with the data. It's just the formation of the packet itself. So we did talk a little bit about this. We showed these header fields.
Sorry,
okay. Yeah, sure.
Can you just explain the overall concept of that diagram? Like, I understand the bits and parts. I didn't understand, like, those are the different layers. Is that what it is?
No, they're not the different layers. So remember, you mean this, right?
Yeah.
Okay, so you remember we were talking about the OSI model, and I don't have it on my computer right now, but we talked about the OSI model with the different layers, correct?
Yeah.
Okay, so so there's something called encapsulation that happens, right? So at layer 7, you're in front of your computer, right? This needs to be translated and sent over to, I don't know, someone else's computer. So first of all, the data is going to be put as that's your PDUs, protocol data unit. So it gets formed into something, right? Let's think of it as you're sending an envelope, right? So you're writing your letter, let's say that's data, then you need to put it in an envelope, right? So that's going to be the transport layer, right? It gets segmented, it gets put into a nice little package, we're going to say. And in this package is going to say, well, this is the port that it's going to leave, and this is the port where it's going to go, right? The next step, which is this layer where we're in right now, is going to encapsulate it some more. And this time it's going to say, well, this is the IP address it's going to leave, and this is the IP address it's going to go to. Then it's going to go to the next level, right? And at that level, it's going to get encapsulated some more. And now we're going to add the MAC address of where it's leaving and where it's going. And then again, it's going to go down one more level, and now there's just bits, and that's going to get sent over, I guess, over the network to your next, to the other computer, the other network it's going to. So these are segmentations, right? I'm sorry, encapsulation at each level. Something else gets added. So at this point, that's a layer 3 header gets added. And that's why it's the IPv4, because here we're dealing with IPs, the internet protocol. So this is just the header that gets attached to the rest of that data.
Okay, got it.
Okay. So I think that we are going to go over what an IPv4 address structure looks like. And you guys have all seen it. If you do ifconfig or ipconfig, you've all seen the dotted decimal notation, correct? So the IP address is actually the network ID and the host ID. And we're about to get over this a little later today because we're going to do some subnetting. But my name is Una Carbani. So if I relate this to the network ID, Carbani would be my network ID, and my host ID would be Una, right? So you'd have to go look in the Carbani family tree, right? Or my network. And there's only one person with this host ID, and that's Una. So the way you can represent an IPv4 address, you can do it dotted decimal, which is the way we read it, or you can turn it into binary value, which is how the computers see it. So it's nicer to write like this because it's easier for us to read. But so it's 32 bits. So each of these are considered bits. If it's a 1, they say the bit is on. If it's a 0, the bit is off. So usually you see it by 8 bits, and 8-bit is called an octet. Okay. Let's see if it explains something. Okay, I'm about to go into my iPad. Anyways, so before I go to the next level, because we're gonna go to pen and paper. So each 8-bit is converted into each respective decimal. So this one is the equivalent. This decimal equivalent is this. The second one, decimal equivalent is this, and so on and so forth. Okay. So I would grab a pen and a paper. And we are gonna go over to my iPad, so bear with me. Does anyone have any experience turning these decimals into binaries and binary to decimal? Show of hands, anybody? Did I hear it, me? Oh, not by hand. Okay, what do you use, a calculator usually? Zakia? Converter online. Okay, well, we're gonna try and do it online, so try not to use the converter. Your calculator. I know there's like calculators and also in your, you can change them even to hexadecimals. Okay, so I'm gonna stop sharing here and I'm gonna keep on, actually, yeah. So I'm gonna actually pause this because I don't know how I'm gonna do the, yeah. All right, hold on a second. Pause recording. Okay, do you see this? Yes. Okay, so the first thing we're gonna do, we're gonna try and convert that decimal 138 into binaries. Okay, so from elementary school, you guys know how to use base 10. So decimals are base 10, right? There are 10 numbers going from 0 to 9. So I know some of you have kids, so you know you've done this probably recently, right? So let's say I was trying to do number 3,000, I don't know, 412. So Doma, I know I'm using something, I'm using my finger to do this, so it doesn't look very pretty. So if we do by base 10 values, right? This position right here would be 10 to the 0. This would be 10 to the first, 10 to the second, and 10 to the third, right? So if I put this position right here, this would be right here, 3 times 10 to the third, and that would be what? 3,000, correct? Okay, then we would add 400, right? Because 4 times 10 to the second plus 10 plus 2, right? Because this equals 1, correct? So that would be base 10, so that's decimal. So now we're gonna go over to binaries, and that's base 2. Oop. Gonna get this, it's gonna be good. All right, so how many bits are in one octet? Anyone?
8.
Yes, 8. So I'm going to make 8 little things right here. Oh, that doesn't look pretty, but it's okay. 1, 2, 3, 4, 5, 6, 7, 8. So just like we started with base 10, we're gonna do 2 to the 0, 2 to the first, 2 to the second, and so on and so forth. Right? Oh, sorry guys. You know what I was writing. Right? So you should know about what these are. So that's 1, 2, 4, 8, 16, 32, 64, 128. So I kind of like to eliminate memorization, right? I don't know if you've ever gone to an exam and you're kind of stressed out and you tend to forget things. I like to be able to go from scratch. That way, if I forgot this, that's okay. I have another way of remembering, right? And if you don't remember 2 to the power of whatever, if you pay attention, each number is multiplied by 2 before it hits the other one, right? So 1 times 2 is 2, 2 times 2 is 4, and so on and so forth, right? Okay, so I don't have a lot of space, but we'll have to deal with this. Okay, so here's how we're gonna do 138. So we're gonna use, well, we're gonna use math anyways, right? So we're gonna go from left to right. So we have the number 138. Can you take 128 away from 138? The answer is yes, right? I'm gonna do green. So boom, 128. So if I do 138 minus 128, I have how much left? I have 10 left, right? Can I take 64 out of that? That's no. Can I take 32 out of 10, right? No. 16, no. 8, yes. So now I'm left with 2. So can I take 4 out of 2? No. Can I take 2 out of 2? Well, yes, I can. And and now I have 0, right? 2 minus 2 is 0. So now I have 0 left. And here's your binary version of that decimal.
Sorry, can you do that again?
Yes, I can. Would you like to go to the next one? Or you want me to do this one more time?
I just didn't get where you were getting the ones and zeros from.
Okay, yeah, of course. So I'm starting with the number 138, correct?
Yes.
I'm gonna go from left to right. So I have 138, I'm gonna subtract 128, right? Can I subtract 128 from 138? The answer is yes. So I'm gonna do 1. So now if I do 138 minus 128, I am left with 10, correct? So I cannot remove 64 from 10, so that's a 0. I cannot remove 32 from 10, so that's a 0. I also can't remove 16 from 10. That's another 0. However, I can remove 8 from 10. Boom. So I'm going to remove 8, and I'm left with 2. So I can't remove 4, so that's a 0. I can remove 1. I can remove 2, right? 2 minus 2. So that's going to be a 1. And so I'm left with 0. So I can't remove that 1 because I have nothing left. So I have nods of approval.
So you can't do so 1 minus 1 doesn't work. That would still be a no, right?
Well, I did 2 minus 2, right? And I was left with 0.
Yeah, I got it. Sorry.
So I got nothing in. Yeah, that's okay. I got nothing in the bank.
Okay.
Right?
Perfect. Thank you.
May I love your Harry Potter glasses. All right, hold on a second. Speaker view. Oh, yeah, the speaker view. Oh, okay, well, that's fine too. All right, so we're gonna do 200. I'm gonna give you a quick minute to try and do 200. The next decimal up there, okay? I'll give you like a good 5 minute. You will have more practice after this. So now you guys are turning 200 into its binary form. More space if I do this. Yes, so much. Oh, it doesn't look good though. You can't see anything. Yeah, it's better this one. All right, how are we doing? You can use a calculator. Can I have like a thumbs up if you're okay and nothing if you're not okay?
I'm okay.
Okay, thank you, Saida. Okay. Shaky. All right, we can fix shaky. All right, let's go with 200, right? So I'm gonna start from left to right. So I have 200, think about it in the bank, right? $200. I'm gonna do the first one. I'm gonna remove 128. So my trusty calculator says 200 minus 128 is going to work, right? So I'm gonna put a 1 up here. Now if I do 200 minus 128, I am left with 72, correct? So can I remove 64 from 72? The answer is yes, I can. So I'm going to remove 64 now, right? And if I remove 64, I still have 8. Awesome. Can I remove 32 from 8? The answer is no. Can I remove 16 from 8? The answer is no. Can I remove 8 from 8? Yes, I can. So now I've got nothing left in my bank. So I'm not even going to bother asking about the other ones. Here's the next binary. How are we doing?
Good.
Awesome. All right, I'm going to let you do 224 by yourself. I'll just give you a minute. I think it kind of helps to have this little table there. I don't know if some people like to have the 128, 64, 32, 16, 8, blah, blah, blah on, but I think it helps down the line. Okay, you guys are ready, or you need more time?
I'm ready.
You're ready. Awesome. Okay, so I got 224 in my bank. I'm going to remove 128. Is that possible? Yes, it is. Okay. 224 minus 128 is 96. So that's happening. Can I remove 64 from 96? Yes, I can. That will leave me with 32. Oops, 32. So I can remove 64, and looks like I can also remove 32, right? If I remove 32, I'm left with nothing. So I can just finish these. I don't need to ask. Okay? Okay. So if you're struggling with this, let me know and I'll give you a little bit more. Okay? Okay. So let's move on to the next part. We're going to do the opposite now. We are going to turn binaries into decimals. Okay? Let's pick blue. Okay, so I see 1, 1, what is it, 5 ones and 3 zeros. Awesome. So now we're doing the opposite, right? I'm going to add every time I see a 1. So this is going to be 128 plus 64 plus 32 plus 16 plus 8, right? So, oops, hold on. 128 plus 64 plus 32 plus 16 plus 8. And I got myself 248. And that is decimal equivalent. Is it a question? Is this a question? Derek, is that from the last one? Yes, it is. Okay, cool. Please do that again. Yes, I can. All right, let me try this again. So wherever the 1 falls, that's the number I'm going to add. Kind of like when you did with the decimals, right? Wherever that 1 falls, that's what you're going to add. So I'm looking at that first binary up there. So I see 1, 1, 1, 1, 1, 0, 0, 0, right? Yes. Okay, wherever that 1 falls, that's the number I'm going to add, right? Which is kind of why it's important to have those numbers there. That way you can kind of quickly reference it. So any number I see, I'm going to add it, right? So I have 128 plus 64 plus 32 plus 16 plus 8, right? That's where that 1 falls, right? Right here. So if I get my trusty calculator, I'm going to add 128 plus 64 plus 32 plus 16 plus 8. All right, still 248. Not too shabby. All right, you're going to do the next one. Actually, just visually, you should be able to know exactly what that number represents.
I have a quick question.
Yep.
How do you know, so you had 248, but then how do you know it's not going to be like 249? You know what I mean?
It would have been 249 if I had this going. Because then,
Oh,
right,
after.
then I would have had to add that 1.
Oh, okay.
Make sense?
Yeah.
Alrighty, let's go to the next one. Just eyeballing it. Do you guys know what the number is? Anyone? Is that an
Just
answer?
eyeballing it, I think the answer is 32.
Yes. Nice.
Okay.
Good. Does anyone not see that? Okay. If you're a little shy, just feel free to chat. Put it in the chat, and I'll be able to see it. All right. The next one. The next one. I know this one looks a little different, so we're gonna do that one. So I'm gonna put 1s everywhere they should fall. 1, 1, 0, 1. Right? So I'm just going to add everywhere a 1 falls. Right? So I got 1, oh, come on, calculator. 128 plus 64 plus 32 plus 8 plus 4 plus 1. And I got 237. 237. Is my math correct? Echo, echo, echo. No one's here. Okay. So we've done this
Here,
part.
I'm just slow.
That's okay. It's just everyone's quiet, so sometimes we never know if we're talking
here.
void. Okay, good. Alrighty, guys. So here's how we're gonna do this now. If you go back to Canvas, and I'm going to pause this video because we don't need that part. Okay, so we did a little bit of conversions. So this is what it looks like. If you ever need, I think it looks a little bit confusing here, so that's why I gave you another way. But just like whenever you did decimal, you would 4 times 1 equals 4. All I told you was just add the number. I think it's an easier explanation. See if you can actually do 237 and 199 on your own, and if you come up with the exact same binary equivalent. Okay, that's for your own practice. Okay, so excuse me. Can you guys hear me? Okay, so now the next thing that we're going to do. So I talked about an IP address being both the network ID and the host ID. And the way that you would differentiate between the two is by using something called a subnet mask. Okay, so the mask is applied to identify the network and host portion, and that's going to be used actually by IP, the protocol itself. And I'll explain as to why it's being used. But for now, just know that a subnet mask has to be contiguous. So the ones from left to right, they never break. So this is not valid, right? From one end to the other. So I don't really want to get into this because I have a better explanation later. But if you look, it's pretty much telling you how many ones there are, right? 1, 2, 3, 4, 1, 2, 3, 4. Remember I told you that this is only going to get harder? So you should be able to look at this and know the decimal equivalent, right? When there's just a 1, you know it's that's the last place on those ticks that I created, that I wrote down. That's going to be 128. And then as you start adding, right here is 64. So that's 128 plus 64. This is how you get that decimal equivalent, okay? So this is going to start looking crazy, right? So this is how it's a process called ending, right? So this is how it's getting done. So the IP address is brought into its binary equivalent, and the mask itself is also placed into its binary equivalent, right? So just so I know that you guys kind of understood, if I had nothing but zeros, what would be the decimal equivalent? What is the lowest it could be?
0.
0, nice. And if you had nothing but 1, so that is the highest value an octet can be, what is it?
255.
Nice, good job, Meredith, I like that. So here's your subnet mask placed as binary. So now the next thing it's going to do is going to figure out the network ID. And the way it's doing that is multiplying it. 1 times 1 is going to be 1. Anything times 0 is going to be 0, right? So 255, you know, is a bunch of ones. 255 again, bunch of ones. 0, I know it's going to end up being 0. And 0, I know everything's going to end up being 0. So 1 times 1 is 1, 0 times 1 is 0, and so on and so forth. And if you eyeball it, kind of look at the logic behind it, right? This is kind of like a mirror. This is also like a mirror. If you pay attention, same number, right? There's a bunch of ones, same number. However, when we have nothing but zeros, boom, nothing but zeros, right? So if I look at this pretty quickly, I'm like 255, boom, I know it's going to be 172. I know it's going to be 30. And since it's nothing but zeros in the back, right? So by like looking at this IP address, looking at the mask, I know what the network ID is. So if this one right here was a 255 as well, what would be my network ID? Am I not making any sense, or am I kind of making sense?
Can you please repeat the question?
Okay, so the cool thing about the 255s is you know they're all ones. So I know what's going to happen is all these ones are just going to make this the same, right? Because if you look at the ending, 1 times 1 is 1, 0 times 1 is 0, 1 times 1 is 1. As you can see, that number, that binary octet, the octet right here, is the exact same as down here because we got nothing but ones here, right? And same thing here, right? Because we got nothing but ones, correct? So if I had a 255 here, what would this number be?
Wait, if you had the 255.
So because I have 255 here, 172, 172. 255 here, 30, 30.
30. Okay.
If I had a 255 here, it would be
15.
Yes, nice. Good job, Meredith. And whoever just spoke, I'm sorry, I wasn't paying attention. Rosie?
Yeah.
Okay, good job. Congratulations. All right, so you're asking me probably, well, why does this matter?
But
This is how IP decides on whether something is within the network or outside of the network. So what it does, it takes the source IP and the destination IP, and it evaluates by using the mask, right? So let's say my subnet mask is 255.255.0.0. What is my network ID here? What is this, my source IP network address?
Oh, go ahead.
What is it?
170.30.00.
Nice. What about my destination address? What is its network ID?
The same thing.
The same thing. So that's how it knows that it's on the same network, right? They both have the same network address. Awesome. All right, now it's going to evaluate. I'm sorry?
I didn't get that. How did we get the destination IP and how did we get the source masking?
So I'm sending something to May or something. It already knows the source IP address and the destination IP address, right? That's the IP, that's the internet protocol, right?
Uh-huh.
But now it needs to know, so off the bat, it doesn't know really where it's going for now. All it can tell right now, is this in the network? Is it in my network or is it outside of my network, right? So what it's going to do first is going to apply that subnet mask to figure out, wait, is it here or are we leaving this network? So what it's going to do is going to grab, where's my mouse? Okay, I don't know where my mouse went. Oh, there it is. It's going to grab the source IP address, apply the subnet mask, and figure out which network it's in, right? So it is in network 172.30.00. Then it's going to grab wherever it's going. 172.30.16.101, apply the subnet mask, boom. Same network address. So we are in the same network. Great, right? Does not need to leave the network. Now we're going to the next one, right? Again, source IP address. Remember layer 3, right? That layer 3 header gives me both the source, so where it's leaving, and the destination IP, where it's going, right? This would be, I don't want to confuse you, but let's say I was sending a letter to May, right? And I put the same, it looks at the zip code, right? We're in the same zip code. So look at it. Where is it going? Where it's coming from? Ah, we're in the same city, right? Or we're in the same zip code location. Perfect. We're staying here, right? But if it was a completely different zip code, oh no, I have to send this all the way to Gaithersburg or something. Okay? This is how it's being done. So here, source IP 172.30.15.12. If I look at that subnet mask, I know that my network address is 172.30.0.0. If I look at the destination IP and apply that subnet mask, I'm at 172.31.0.0. So they are not in the same network because the network ID is different. So that would be two different zip codes here.
Oh, because that one is 31.
Exactly.
Okay.
And remember, I told you to eyeball things, right? So if it's a bunch of ones, I know that those first two numbers are my network ID, right? They're going to mirror it. So this one, 172.30.0.0, this one, 172.31.0.0. Yes?
No, I don't get the last two numbers, the 16101. It doesn't have to match the source IP.
No. So I'm going to do, since it's getting a little confusing, I'm going to do some on my iPad. That way you guys can see what I'm doing, okay? Stop sharing.
Cool, thank you, Una.
Yeah, absolutely. Okay, share, screen, start broadcast. All right, let me try a new one. All righty. So I'm gonna give you another IP address. All right. I'm gonna say 10.10.10.0. I don't know. I made that up. All right. If I told you this is the subnet mask, what do you think the network ID is going to be? I know that based on this right here, I know these are a bunch of ones. I know that anything that's multiplied by 0 is going to be 0. So I already know this is going to be 0.0.0. I'm not even going to worry about those ones, right? However, all these are a bunch of ones. So I know that 10 right here is going to come down here. So this right here, network ID. So if this was my destination address, if this was my source address, and this right here, I don't know, still making up numbers, guys. If this right here is my destination IP address, is it in the same network or is it not in the same network? So I'm going to remember, I'm applying the exact same, sorry, let me get another color. I'm applying the same subnet mask, right? So this is the subnet mask I'm using. This is the destination IP address. So this is where my all my packets are going to go to, right? Since this is 250, yeah?
The mask is which one? 255.0.0, right?
Yeah.
And the IP address is the 10.10.10?
That is my source.
Your source.
And in blue, it's going to be my destination IP address, correct?
Uh-huh.
Okay. So 0, 0, 0. I know already where I'm going with this. And I'm not going to worry about it. Right? This leaves me with 255, which is a bunch of ones, right?
Uh-huh.
And I'm looking down here, right? So I know already that this is going to turn into 10.
Yeah. Mm-hmm.
Right? I mean, if you guys are in the...
I get
have
that.
so much... okay, awesome. I was going to say, if you have so much time on your hand, you could try ending, but I'm trying to teach you how to eyeball it, right? Because this would look like a bunch of, what? It would be 0... What is this? Well,
I don't understand how you got 128 and 192.
Oh, I made that up.
Oh, okay. All
That's,
right.
yeah, that's another IP address. No, I made that up.
Okay,
Okay.
great.
Okay. All right. So I'm gonna give you guys another one. 192. And I'm gonna put 255, 255.
Okay, so it's 190. The destination is 192.10.10.
0.0. That's not.
Point
I'm
zero.
gonna make this the source. Okay, this is gonna be the source, right? Right now, all I want to know is the network ID. So the network address. That's what I want to know. I want to know the network ID, right?
192. Is that right?
Yeah. Are you done?
Oh, 0.10.
Uh-huh.
0.10. I guess 0.0.
Yes, 0.0. Let me change this number so you guys are not. What can I put here? I'm gonna put 16 here. Okay. All right. I hear a lot of quiet people. If you're confused, please give me a shout out. Like, let me know, okay? I'm looking also at my the text message, the chat, just in case you guys can't tell me that you're in trouble. Okay, so now what is the ID now? What is the network ID? Anybody?
192.10.10. Is that 16?
That is 16.
Uh-huh. Point
You want
16?
16? No. This is a source IP, right? And I'm matching this right here. So
0.
yes, it was a 0. Well, you waited for me to delete this. So everywhere there's a 0, that's a 0 right here.
Okay.
Now, these are a bunch of 1s. So I know that when there's a 1, it's just going to be the exact same number up here.
Okay, that's what was confusing me first. Okay.
Right. So the reason why maybe some of you are confused is you cannot figure out what 255 is in binary. 255 in binary is 1111 1111. All ones in the octet, right? For example, 10 would be what? It would be 0 1 0 1. I want to say, yeah, 2 4 8, and then 0 0 0 0. So I'm talking about like these ones right here, right? So this equivalent is 10. This equivalent is 255. So if I did some ending here, right, I would have, and I don't know if I can write this close, this would be 0 0 0 0 1 0 1 0. That would be ending, right? If I multiply each number from top to bottom, right? And what does this bottom number equal to? 10.
The network.
10. I'm ending here. But instead of having you turn all of these into ones, into binary, and all of these into 1 to get this number, I am telling you that if you see a 255, it's going to be the exact same number. 255, same number. 255, same number. 0, definitely a 0, right? 0 times anything is 0. Do not
So could the 255 be a different number, or is it just going to be 255 and zeros?
Say that one more time.
Is it only going to be 255, or can it be like 255 and another number? I mean, could it be another number and 0?
It could be 254, actually. And that is when you need to start worrying, okay? Because that's when you'll have to do what I did at the bottom, right? So right now all I'm asking you is to eyeball it. But let's say that it is 254. So here, and this is later in the PowerPoint. Right now what I'm doing, I'm doing what's called default subnet mask. These ones are customized subnet mask, but I'm not there yet. But if this was 254, 254 looks like what? Remember, 255 is the highest number you got, right? 255 is the highest number you got, so logic dictates that 255 minus 1 is 254, correct?
Yeah.
So in the end,
Mm.
I'm sorry, no, that's not what I wanted to do. Hold on a second. Oops, come on, play with me. Okay, 254, right? That would be this number right here, correct? And what does 16 look like? Anyone? So definitely 128, 64, 32, 16. Boom, 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 boom. So this would look like 0, 0, 0, 1, 0, 0, 0, 0. So that would look a little bit different. And you'd have to compare it. So if it's getting compared to another, if it's getting compared to its destination IP address and it looks slightly different, then you know it's no wrong network address. But we're about to do this a little later, so let's not get confused, or else I want to make sure we got this pat down. And after that, we're gonna go on a tangent, okay?
Mhm.
All right, so your next, how are we doing? What time is it actually? Sorry, oh, it's 10:30. Oh, okay. So let's take a 15, 20-minute break, and then I will direct you to the next exercise, okay? If you did not want to tell me that you were having an issue, let me know right now and I will help you, okay? Like I said, it's only gonna get harder. All right, so, hold on, let's see. Meg, the answer to that question is yes. All righty. So, what's going on? You're going to work. Great. So if we kind of think about the routing basics, right? So this is what happened. IP takes the source IP address and destination IP address and decides on whether, actually, hold on one second, guys. All right. Sorry, I had to pause for a little while. Let's go back to this. So the first thing that IP, so Internet Protocol, would do, it would grab the source IP address and the destination IP address. It would apply the subnet mask. And if it realized that it was not on the same network, it would use ARP, which is Address Resolution Protocol, to figure out where the default gateway is. So where the router is with the default gateway. So I think, I'm not sure Josiah had explained it last time, where it says, who is this? And it says, oh, I am this for like the MAC address and the IP address and whatnot. So first of all, it would need the default gateway to make its routing decision. Now, if the packets are too big, this is where fragmentation would happen. Checksum did talk about it, and time to live would be per the routers, right? So if it was within the network, what it would do is it would also send that ARP message to find out, hey, who has this IP address? And per the routing table matches an IP address with the MAC address of, let's say, a host. So it would say, who has 10 dot blah blah dot blah blah dot blah blah, and it would send it to every host within that broadcast domain, and eventually one of them would answer, that is me. MAC address to IP address, it's me, you can send it to me. Okay? So that's where this routing table, that's what this means. Okay? And then time to live, I think I talked about it. It has to do with, like, for example, hops. So if it's getting sent out of the network and eventually it gets lost, it's there on purpose so that it doesn't bug up networks, right? So it gets decremented one at a time, and eventually when it hits 0, boom, it gets dropped from the, one of the routers will drop this packet, okay? I believe, did you guys do the, I did the network addresses, right? Yes, we did network addresses. So the next thing is the first activity, IPv4 addressing components. So that's going to be 4-1. And I'm going to pause this. You are muted.
Yes. What'd you say?
Are you ready for topic B?
Sure. Give me a second. Topic B is going to be testing IP interfaces with command line tools. So basically these command line utilities are going to let us gather information about our systems and how they're going to communicate and be configured for our IP network. So we can use these when we troubleshoot, maybe figure out some communications issues or maybe some of the causes. All right, so the first up is IP config. You guys saw me try to mess with it. I was able to do it, but you guys weren't because IP config is kind of being deprecated at the moment. And so they are no longer, you had to use sudo to use it in Kali, but I am able to do it on mine because it hasn't been knocked off of mine yet. And you can, the new one is IP. I believe we're going to talk about that a little bit later here. But when we type in IP config or IF config in Linux, which is actually what I wrote, we can get information about our current system. So IP config will display our IP address. It will display, so here we have our IPv4 address. It'll display our subnet mask. There are a couple different, let me see here. Okay. There's a couple different options you can put on there. So we could say IP config renew interface, and that will give us a new lease on our IP address. We could say release interface. That's gonna it's gonna give it's gonna make sure the interface no longer has an IP address. We can flush the DNS. We would say IP config flush DNS. We can register the DNS, and it will register the host with the DNS server. And we could do IP config all, so that will tell us all the configuration parameters that all of our interfaces are using currently, because sometimes we might have multiple interfaces. So my computer, if you saw mine the other day, I was actually having a ton of different interfaces, more than I was aware of. So we have the, well, actually IP config will show you the default gateway. IF config does not. So this is IF config for Linux, Unix, IP. So IP is the new command. So this is going to be intended to replace IF config. It's supposed to be more powerful, but it basically has the same functions as IF config. You would just type in IP space A. Ooh. Okay. All right. So ICMP. ICMP is it's used to report errors and send messages between computers about the delivery of packets. It can be used to test and troubleshoot connectivity issues. And a lot of times they're generated under error conditions. So ICMP message types, there's going to be there's ones that are echo requests / replies. So these are going to be used for testing connections with the ping utility. So we might have saw that on the NetSim. If not, we'll get a chance to do it. So we're going to send request messages to a host, and if it generates a reply and sends it back, then we know that we're able to reach a destination. There is some connectivity with that server. If not, we will get a message saying that it did not reach its destination, and that will tell us that we are not getting connection there. We can also get one that says destination unreachable. So sometimes it could just die, or we can get a destination unreachable. So this is likely going to be caused by some error with the host, or it could generally just have a router down somewhere. We could have time exceeded. So when we talked about time to live, so the maximum value of time to live is 255. So usually this is counting down by hops between routers. I believe it can also be in seconds. But once it reaches 0, then the time will be time to live is over, and it will be exceeded, and it's going to be discarded, and you'll get some sort of warning packet back to the source. Redirects. So most of our host channels are going to direct the communications through a default gateway. And so if they can find another route, it will go that way. But it will let you know that there was some sort of update to the routing table, and that's that redirect message. Well, it's going to let you routing table. No, in that case, maybe not you. Because in these routing tables, they create like a map, right? So if they have to redirect, then they update it. All right, so ICMP, once again, so these are ping requests. So request, reply, request, reply, request, reply. So ping is a utility that sends usually like 4 ICMP packets. And so this is going to help us do those connectivity tests. And then all we're going to do is type in ping and then maybe either the host name or the host IP address. And so if the ping is successful, then it's going to give you a message that says reply from whatever IP address it was. And then it also will tell you the round trip time. So that's going to be RTT. And so maybe that will help you determine that we have a slow link somewhere in between on these routers. We could also have the time to live counter. So that's going to tell us how many hops it took to get to where it was going. So maybe it says like 12 hops to get to Google or something like that, right? Or it's going to tell you it couldn't reach it. And so if it has no routing information, it doesn't know how to get to the IP address, it's going to tell you the host is unreachable. If the host is on your same network, then you're probably going to want to check some sort of physical cabling or something. If the host is on another network, you might not be, you might have to check out the IP configuration or something like that. But if you get no reply saying like the request timed out, then in that case, the host is unavailable completely, or they can't route away to your computer, meaning it's completely, there's no connection there at all. And then also, we should know that ICMP is blocked a lot because people do Smurf attacks, which I guess the reason it's called Smurf is because IP packets are very small, and we can flood a server with them, and so they send 4 back, we send 4 in, and so it could kind of flood that server. So I'm assuming it's because they're small. And so here's an example of the ping to 127-0-1. So 127-0-1 is actually a loopback address. So this verifies that that we actually have TCP/IP and everything, because this loopback address is reserved for testing. So we know that IP and TCP stuff are working, the internet protocols. Then next we can check out the IP address. And is this 192? Yes, this is 192. So in this 192, all right, so in 192, we are pinging ourselves because that is most likely a local IP. Well, it is a local IP, so I'm assuming we are pinging ourselves here. So in this case, we're verifying that our workstation is actually working properly. And then we have, we could ping next up this 10.0.0.1. That is, it's going to be the default gateway. So we can verify that we're running, and we can communicate with another network, right? And then finally, we can ping, they don't have one. But then finally, we would ping like the remote host. So the remote server, Google or somebody, to verify that we can connect to them. So this might be the path you might take to verify what's going on your network. So we could ping the loopback address like they did, the host IP address, the default gateway, and then the remote host. All right, so ping switches. Ping switches, these will allow us to adjust the time to live with -I. We can adjust the timeout with -W. We can force it to use IPv4 or IPv6. We can resolve host names, meaning show the host name, and we can run this continuously where it's going to keep on pinging until it's stopped. I believe ifconfig keeps pinging until it stops, and ipconfig, one of the two keeps pinging until they stop. The other one only goes 4 times. I believe ipconfig does it 4 times, and if just continues to do it. But remember, one is for Linux and one is for Windows. So ipconfig is for Windows. All right, so the first activity of lesson B is going to be discussing IP interface testing.
All right, we are back from break. And we're going to start with talking about addressing, right? So this way of setting up IP addresses is deprecated. So this is how it started. I think that was in the 1980s. They divided the IP addresses in classes. There were actually 5 classes: Class A, Class B, Class C, and D and E. So in this class, we're going to focus on the first 3 classes. The last 2 classes, one is for multicast addressing, and the other one is for experimental. Actually, I believe that even the military use them. So they're reserved for other purposes than unicast. Actually, did I skip? I did. Of course, I skipped it. Okay. So there are 3 types of traffic, right? So one-to-one, that's unicast. So that's me talking to May only, for example. There is multicast, so one-to-many, so that's maybe me talking to Josiah and May. And then there is broadcast, and that is talking to the whole class, for example. So don't worry about the in-depth stuff that you see here. Just know that there are 3 kind of traffic, for example, and we are only going to worry about the first 2, unicast and broadcast. So I'm going to break it down. So first, let's go to class A through C. So the first class, so we talked about the network ID and the host ID. So only the first octet is dedicated for the network ID, and the 3 last octets, are reserved for the host ID. So what that means is that we have a smaller number of network, and we have a greater number of hosts per network. As you can see, we have a lot of different combination, if you think of 1s and 0s, giving us a whole lot of hosts per network. So the one thing, though, is that your first octet is ranging from 1 to, actually, it says 126, but I'm going to explain to you a few things. If you look at it, the first digit, the first bit has to be 0. So if all of these were 0, you would start at 0. And if all of these were 1, you would end up with 127. The reason why, and if you Google it right now and ask for Class A IP addresses, this number tends to vary. And the reason why is 0 is, all zeros is reserved for, it's reserved for something, and 127, as you saw Josiah talk about, he talked about it earlier, is reserved for the loopback address. So that's why you see 1 to 126. I guess we'll talk a little bit more about, about the other special IP addresses. Just for now, know the classification. If it falls between 1 and 126, you get yourself a Class A range IP address, okay? Then we have Class B, and so the first 2 octets are dedicated for the network ID, and the last 2 are dedicated for the host ID. So as you can see now, we have a greater number of networks and fewer than this one, right? But you still get a great number of host addresses. And so 128 to 191, so always the first 2 bits have to be 1 and 0. So if it's nothing but 0, all the way down, right? Well, yeah, you got yourself 128. If it starts to change, sorry, it's only the first octet, right? So 1 and nothing but 0, you got 128. 1, 0, and nothing but 1, it's a greater number. Again, just mind, so it would be 121 actually. I would say, so if I gave you what class range is 130.10.10.10, you would answer it's class B, because it is, the first octet is between 128 and 191. So now we have class C, which is the complete opposite of A. And as you can see, we have a greater number of networks, smaller amount of a host per network, and your first octet ranges from 192, so right after this one, to 223. So just understand that the first 3 bits have to be 1, 1, 0. So if all this was 0, you start at 192, and if all these were 1, you'd be at around 223. The one thing I wanted to let you know, right? So eventually classical addressing has been deprecated, because what happened with cutting IP addresses in just these 3 classes caused, so the reason why we're moving to IPv6 from IPv4, and it's a very slow process, is that we're running out of IP addresses, right? And for example, if a company wanted, I don't know, 10,000 IP addresses, they would need to have class B, but look how many they're wasting. They're wasting over 40,000, right? So what happened is, because of this huge gap, class B addresses were getting depleted faster. So they decided to move on from classful addressing, and now they have something called classless addressing. Oh, so before I go to this, actually, maybe not. So looking at, I'm going to go back to the previous slides, but when it comes to addressing, remember that the first couple of, the first couple of bits, so the first 16 bits were, this is for class B, right? The first 16 bits were dedicated for the network ID. So when we're talking about subnet, the subnet mask, that means that the first 16 bits, 1111111, you're going to have a 16-bit octet mask, right? That mask is going to be at 16. But whenever you go to class A, it's only the first one that are going to be dedicated for the network ID. So you're going to have a /8. It's going to be an 8-bit octet mask. And whenever we go to class C, the first 3, if you remember, were dedicated for the network ID. So we would have a /24 octet mask, okay? So I kind of want to practice that before I go into the whole subnetting design, because I think it would get a little bit complicated. I'm going to pause this. I'm recording. All right, guys. So now we're going to talk about splitting those huge networks. So let's say I have a huge network. What happened is that it is part of what's called a broadcast domain. And I know that Josiah talked about broadcast domain. So you have all these hosts inside of one room. And if you think about it, if I boil it down to what this means, if we were all in a room and there's maybe 50 of us and we were all talking, not only is the room noisy, but which makes the workplace quite inefficient, right? So if we were about to break this into breakout rooms, kind of like what we have here, or other smaller rooms where a few of us, maybe 4 at a time, could work there, it would make, I guess, the work area much more feasible, right? You could actually study, you could hear the conversation. So same thing with a huge broadcast domain. All of a sudden, you have a lot of traffic going on. And it also makes it harder for administration as well as security, right? It is better to break up your network into smaller network for security purposes, because now a bad actor would have to find a way to get into the other networks. So a couple ways to split up a broadcast domain. A router would not allow, so if we were to send a broadcast, those broadcast packets we're talking about across our broadcast domain, they would not go into another broadcast domain. The routers do not allow it to go from one broadcast domain to the other. So a router breaks up the broadcast domain. Also creating VLANs, which I think we'll go deeper into VLANs. So don't really worry about VLANs right now. I don't think you guys, I think we might talk about VLANs tomorrow. Another way to have a different broadcast domain is to create VLANs. I don't really want to go into the other part, but for now, just think of it that way. So if you look, I think this, okay, yeah. This is a VLAN. It comes out of a switch. I'm not going to go into this right now because I feel like we're throwing a lot of information at you right now. But just know that instead of having a huge network, it's broken now into smaller network, and each of them have their own IP address. Okay, so give me a thumbs up when you're ready. Okay. No, okay. So this is how it was going on. So this is, we talked about the old class terminology. These are going to be called default subnet masks, right? And they're lying along the octet boundaries. So remember in the network ID, so obviously if it's 16-bit and 16-bit, we're talking about a class B right here. So it's been broken down right along those octet lines. So you have 2 octets in here and you have 2 octets in here. The first 2 octets, because this is a class B, dedicated for the network ID. If that network ID was smaller, if it said 8-bit, we all know that's a class A, right? So before, this is how it used to be broken down. And if I was writing in CIDR formation, this would be a /8. And why am I saying a /8? Is because the first 8 bits are on. This one, can someone tell me what would be the CIDR annotation? The slash, what number would I have here?
/16.
Nice. Okay, and for class C, what would I have? Come on. What would I have for class C? You were right for class. Yes, /24. Awesome. So now we find ourselves, we want to break those networks into smaller networks, right? So what is going to happen? And IPv4 did not expect this, but what they did is they need to break this down so that we can start using a little bit less of those IP addresses. What they end up doing is leave the network ID alone, but go ahead and borrow some bits from the host ID section. So okay, hold on. I have a question. So let's say that I'm in team red, and we need to break team red into a bit more. Okay, give me 1 second. So if we're in team red and we need to break team red into like two other groups, maybe now the network ID is team red, right? But now we're like team red number 1, right? And the other group is team red number 2, right? We had to we had to use a little bit of these host ID to decipher between the 2 different subnets or the other subnets that are going to be created. Okay, so I know I'm starting to, hopefully I'm making some kind of sense. No worries, we're about to be spending some time on this. So I'm going to pause this. Hold on, May. Okay. Let's get together. Okay, so here's where we were, and we're going to start talking about default custom subnet masks, right? So we talked about the default subnet mask that was aligned along the octet boundaries. Now it's going to start looking different, right? That's why I didn't want to add it. I didn't realize it was part of the quiz in 4.1. But now that we are here, we're going to start talking about how bits are getting borrowed, and that subnet mask is going to change, right? So the host ID all by itself. But now the subnet mask is going to get added to that network ID, right? So now my sorry about that. Now my subnet mask is going to start looking different. Instead of saying /16, it's going to say /20, because I am adding the bits that are getting borrowed. So as you can see, we have 16-bit here plus 4, we got 20. So now all this will let me know what part is not the host ID. So I have a host ID, and then I will have a different network. Well, it won't be just a network ID at this point. It'll be the network ID plus the subnet ID, okay? All right, so now we're getting into classless addressing. So this is what I was talking about. So /NN is the number of bits in the mask, right? more compact and easy to understand. So actually, we explained this a little earlier. /8 is going to be class A. And why is that? Why is it /8? Anyone?
Because the first 8 bits go to the network or something like that.
Yes, that's right. The first 8 bits are on, so it's going to be ones, right? So your subnet mask is going to be 8 bits that are on, and that's going to be the first octet, right? Since it's by 8. And class B is the first 16, right? So that's 2 octet, and class C is the first 3. So that's the first 3 octet, which is 24 bits. So these right here, we're going to remember them as, if I can find my mouse, we're going to remember these as your default subnet mask, okay? And we're going to start talking about changing it up because we're about to start subnetting, okay? So I'm going to stop sharing here and I'm going to go straight to my iPad. So I think that after this, I'm going to pause to make sure that we're all kind of on the same page, okay? Because I know that some of you feel a little bit behind. I'm going to add also, if this is really, really hard for you, it doesn't mean that it's time to go, okay? Just give us a second. We will explain. I will do my best to explain to you as much as possible. If you dread this absolutely, then maybe that's the point where you kind of question yourself, right? Do I really want to do this? But if not, don't just do this and you're like, yeah, I don't get it. I think for some people, it takes a little longer. I think my last cohort, it took them a day and a half to understand what I was doing. And even that, I don't know. Sometimes I think some of them just really hated it anyways. So, all right. So looking at this IP address, just eyeballing it, what scream at you? What can you tell me about this IP address by itself? Anyone?
Class C.
Class C.
Nice. How do you know that?
Because it's over 192.
And before 223, right?
Yeah.
Lovely. I like that. So what is the subnet mask? And that's what they call it.
255.255.255.0.
Awesome. So that is the default subnet mask. Now we have changed the game a little bit, okay? Now its subnet mask is now 26. So you guys remember the custom was at 24?
Yeah.
Now I've changed things. Now I have bled over, I want to say, the octet boundary. Now we're at 26. How many bits am I borrowing? Just doing the quick math. If it was 24 and now it's 26, how many bits am I borrowing?
2.
2. That's right, Saida. I'm borrowing 2 bits for that subnet, for my subnet ID.
Why?
Okay? You did not understand that. That's okay. So
is that like 2 extra because they're supposed to be 24?
Yes.
That's correct. Yes, that's exactly what this is. All right, so now I'm at 26. So you guys already said my default subnet mask is 255.255.255.0. We're in agreement?
Mm-hmm.
Okay. So now this right here, so here it was /24, right? Because they were behaving, right? They were staying within the octets. But now I have bled into here. So if this is a bunch of ones, right? Now I'm going to, one of you said it. You said how many did I borrow? How many bits did I borrow?
2.
Someone said
2.
2. Yeah, all right. So in this very last octet, I have 2 borrowed bits. So this is no longer just 255.255. What is this now?
128 plus 64.
What,
Really? The instructor
192?
is answering this question, May? This is how much she loves subnetting, you guys. We're about to leave it only to May because she absolutely loves that stuff. Okay, what is it?
192.
192. And how did you get that information?
The ones are in the 128 and 64 spot.
That's right,
Okay.
128 and 64. So if you add that, you get yourself 192. Okay, so that is now the custom subnet mask. Okay,
No, I don't get that.
you don't get that. Okay, let me do this again.
How
So,
1100, like all of that.
okay, yeah, I like that. So here I have a total of 24 bits. Do you agree with me? 24 bits that are on, right? Remember, that's the subnet mask. It starts from the left, doesn't skip anything, right? And we know that if it's a class C, it's going to be at 24, correct?
Uh-huh.
So I know this, right? This is class C. However, my subnet mask looks different. It's a 26. It's not 24 anymore, right? That means that I had 24, but all of a sudden, extra bits have been added. So 24 plus 2, 26, right? Do you understand this part?
Yeah.
Okay, so this is my new subnet mask, right? So before we were just class C, but now I've decided I wanted to create little subnets. So now for my subnet, remember I told you for a subnet, you have to borrow bits from the host ID, the host section. We're borrowing bits to create that subnet ID. So I've borrowed an extra 2 from this area, right? I borrowed an extra 2. Here they are. So instead of 24 for class C, now we're at 26. So 24 plus 2 equals 26, right? So that is what? 1 octet, 2 octets, sorry, oops. 2 octets, the third octet to make 24, and here's the fourth octet, and that's going to be 26 bits that are on for the subnet mask.
Okay.
Okay, I'm going to change it. We're going to do another one. So we've done other whatchamacallit.
Sorry, quick question.
Yeah.
We won't know the 26. Like they have to give us the 26, right? We can't figure that out on our own.
Yeah, no, it'd be written. And also when you do ifconfig, you will also see a subnet mask there.
Okay.
Okay, I'm going to change this to 28. So what I was trying to say is we've worked before with other cohorts and we've decided to keep it at class C. If I bring a class A and class B, that is a whole different monster. So we're going to leave those alone, okay? So what is, I mean, I already said it, but what class is this?
C.
All right. What is the default subnet mask?
24. Oh no, 2.
Right, yeah, okay. So 24. And what does that look like if I write it down, like the decimal equivalent?
255.255.255.0.
Nice. Okay. So now let's look at so I'm going to also do this in binary. Okay, so now I'm just like, technically this is going to be a bunch of zeros for now, right? If this was the default, right? However, now it's been customized, right? So how many bits am I borrowing?
4.
Come on. Yeah?
Yeah.
Okay. So now what is this address? What is this custom subnet mask look like? 255.
255. 255. Wait.
Go ahead, pull out your calculators.
Yeah.
Or if you're awesome like that and you know your math like down pat, I'd be very impressed.
128 plus 64 plus 32 plus 16 that 240?
Yes, that is the custom subnet mask. Thank you, Saida. That's very good, guys. All right, I'm gonna give you 2 more that you're gonna work on. I should stop deleting that by yourself, and then I will reconvene with you. And you give me a thumbs up whenever you know that you're good, okay? So we're gonna do 30, and we're gonna do 29, okay? So I want to know the default subnet mask and the custom subnet mask.
You're using class 3 still for these numbers? Yeah. Oh yeah. Okay. I might. Yeah.
Yeah, I'm not going to leave class C because I will be opening a can of worms that I don't want to open.
Okay.
Hey, Mike, can we go to the breakout room while they work on this really quickly?
Sure.
By the way, guys, feel free to ask each other questions. You know, you guys are all here together. It would be a shame, which is why it's nice whenever people talk to each other, you know, and see each other's faces, but you should definitely ask each other questions. Don't send Una C, send just Una and you, okay?
Okay.
Thank you.
The 3.
Oh, I'm still recording. All right, I'm gonna stop the recording in the. Hold on before you send me away. Did you guys write this down? Please write it down, okay?
Yeah.
Uh-huh. Oh wait, I didn't write the other one down.
It's the same thing except it's 29 instead of 30.
Okay, thank you. 30.
All right, guys. So this is what I left you with, right? So we already know what class this is. What class is this again?
C.
Okay, cool. So class C, and I know it because of that first octet, it's between 192 and 223. Awesome. So remember, after 223, we're dealing with class D and class E, and these are multicast address and experimental addresses. We don't deal with them. We're dealing just with unicast right now, right? And 200 happens to fall in class C. So I already know what my my default subnet mask is going to look like, correct? It's going to look like this. Well, if I were to write it in that annotation, it would just say /24. Yeah, that will look like 255.255.255.0, right? Because each of these are 8 bits. So if, oh my God. So if
Sorry, Una. Can we have you 2 minutes, please?
okay, give me 1 second, guys. Okay, awesome. So I'm gonna record one day. I'm going to who needs to be muted? Okay, nobody. All right. So I said that. So we know it's 24. Now I'm asking for 30. So how many bits were borrowed? Anybody? How many bits were borrowed? If I know
6.
this, 6. Nice. 1, 2, 3, 5, 6. So that means that the rest. Oh, I should have done this in another color. Hold on. 1, 2, 3, 4, 5, 6, and then the rest is going to be 0, right? And I know it's 2 because it's 8 altogether. Okay, awesome. So now, what is this custom subnet mask going to look like? What is this equal to? Calculators at hand. So I know it's 128 plus 64 plus 32 plus 16 plus
252.
plus 4. And you got 252. That's right. Is it 252? Yes, it's 252. Actually, you know what I could have done? I could have done 255 minus 1 minus 2, and I would have gone 252, right? Instead of adding all those prior numbers. Anyway, so this is the custom subnet mask. Okay? So if I was doing the other one, which is 29 now, what would this look like? How many bits did I borrow compared to the custom? Anyone? How many bits am I borrowing? I see 5. Yes, that's true. 5. Good job. What is this? Nihon. Okay. So I'm at 24, 25, 26, 27, 28, 29. Nice. And then let's do another color. So 1, 2, 3, 4. 1, 2, 3, 4. Yeah. So that's 8, right? So now what is so we were at 252. So if you take what is this? 124, so minus 4. Let's see. So what do you guys have? Am I correct? 248. Yes, nice. Look at Nihon like going faster than everybody else. I like that. Awesome. So how do we feel about this?
You just subtracted backward?
Yeah, because before, whenever I was at this, it was 252. And I know that this right here is equal to 4. So I just subtracted 252 minus 4, and I got 248. But if you wanted to do the long way, right, you would add 128 plus 64 plus 32 plus 16 plus 8 plus 4.
What
Right?
does the dash mean? Like the lie that you put, like, I don't, the number, I think 1 and 0.
You're talking about the octet right here?
Yeah. I just
So,
use 255 and then like minus what number is left. I don't do that one.
what did you do?
Yeah, I just subtract out how many bit that we borrow, and then like use 255 and subtract out the number that are left.
Yeah, that's good too. So for this one, you would have done 255 minus what? Minus 1, right? You had 254. Then you did what? Minus 2.
Minus 2 and minus 4.
252 and minus 4. Yeah. It's just a different way of doing it. It's like saying 2 plus 2 equals 4, but so does 2 times 2. I mean, it's just a different way of going about it.
Oh, okay. So I don't have to do the other way that you did, right?
No, you don't. If you're getting the right answer, then you're doing it correct, right?
Okay.
Yeah. How are we doing?
Good.
Good. Okay. So the thing is, after this, it's like running uphill. We're climbing more stairs. So I kind of want to give you guys a little bit of time to kind of absorb this before I throw you into the other stuff. So there's more to this. There's figuring out how many subnets there are, figuring out how many hosts there are per subnet, and figuring out the ranges of the subnets. So I kind of want to give you time to kind of, I guess, absorb this material before I throw you into the deep end, right? I think I'm going to pause the recording. I'm going to post it. So if you miss some parts, you can always review it. If you want to go further, hey, there is a bunch of material online anyway, right? But tomorrow we're going to be running a little bit more, okay? For now, we're going to go into a little bit more Linux. And while we're doing this, I will pull some of you because I know that you might need extra help, and we'll go back through the basics, okay? But if you're good, please go on that Linux, and we'll be good, okay?